All right, welcome on our last video on area and volume, my friends. So let us go ahead and get started. Let R be the shaded region by the graphs of y equals square root of x and y equals e to the negative 3x and the vertical line x equals 1. Find the area of R. Now, believe it or not, this is a calculator active question. And I do believe that this could be non-calculator active as long as we were given the point of intersection. So as you know, we need to find the area of this, and as I alluded to, we need to find that point of intersection. Since it's not too long to do this, I'll go ahead and graph it. Look at your bounds. The x values go from 0 to 1, the y values go from 0 to 1. So I'm going to go to my window before I sketch this and go to 0. And I'll do my x values 1.5, just a little bit more than what I want so I can see a good picture. Y minimum is 0 and my y maximum is 1.5. There it is. Let's go ahead and hit graph and let's see what we get here. Shaboom, right? We see the exact same image. Obviously x equals 1. It's cutting it right here in this little section. We don't got that though, and that's okay. Second, calculate. Let's go to intersect. Points of intersection. First curve, as long as I'm in the first curve, we are golden. I'm just gonna get near it. First curve, boom. Second curve, boom. I hit both curves. That way the computer can calculate the intersection for us in between. Hit enter, and there it is. We got our points of intersections, and I like to personally write down both the x, y value and y value. So point of intersection is at 0.238734, 0.488604. So I'll write the point of intersection. I got my x value and my y value, and you never know when you're going to need the y value, so that's why I want to put it and save myself time in case I need to utilize this in any kind of problems as we go through. So we want to find the area. Well, it's just the area. We don't need to do any fancy rotations. It's big R minus little r. Big R minus little r. Sorry, now I said rotation. It's just top curve minus bottom curve, right? We're just finding the area. We're not doing no fancy rotations. I've already tripped myself up. So top curve minus bottom curve. Well, quite frankly, which equation was what? Well, hopefully you focused in when we were sketching these. We got an idea of what was what, but I kind of know, but obviously you want to take note. Top curve is the square root, and e to the x is the bottom function because it's e to the negative 3x, which is actually 1 over e to the 3x. So you should expect it to decay instead of grow. But anyhows, there it is. So top curve minus bottom curve, that is from, well, 0.238734 all the way to 1. Top curve minus bottom curve, that's the square root of x minus e to the negative 3x. Boom, dx is equal to, use your calculator again, y1 minus y2, and you'll get 0.442. Bam, done. All right, that's 2 points for us there. Now we'll just go ahead and move on to the next question here. All right. Find the volume of the solid when R is revolved around the line y equals 1. Well, we've have done this quite a bit on the previous videos, and if we do y equals 1, what we're really going to get, in this case, since we are rotating this about the line y equals 1, right, we're going to get some kind of shape, boom, up there. I guess I'll scroll up just a little bit for you guys to see it. Not the greatest drawing in the world. Not the greatest drawing in the world whatsoever, but we're gonna get, yeah, something like that, right? And we're obviously gonna get a hole, and then we're gonna get that volume of just this region in there. And if you think about it, obviously I don't got the best drawing skills here. Oops, around here. And you're gonna get, you want to get that volume of this in here, and you hopefully can see kind of the resemblance of that shape. And we're gonna get a hole. So big thing is we're gonna get a hole, which tells us we're gonna do big R, which obviously big R always includes what we want and what we don't want, and we're gonna do little r, boom, which is getting rid of the hole, right, the parts that we do not want. So what is big R? Well, big R is 1 minus, well, we want to subtract this curve right there. So 1 minus e to the negative 3x, and little r is going to be 1 minus, well, how do we get this length right here? That's from the function the square root of x. So our integral will be pi from, well, 0.238734 all the way to 1 big R squared 1 minus e to the negative 3x squared subtracted by little r squared 1 minus the square root of x squared dx. Bam, we are in business. Plug that into your calculator and we get 1.423. All right, there it is, and we get our volume of that small little shape there. Here we go. Maybe this is the challenging one. This is maybe the one that most of you probably came to see and do, because I'm sure some of you felt pretty confident by now on A and B. So, how do we do this? How do we do this? Well, first things first. Region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis is a rectangle. Ooh, so we got a rectangle in here, right? We got a rectangle. Not a square, a rectangle. Well, that's the only, we worked so much with squares, right? We worked so much with squares, and a rectangle, let me draw it. Well, it's just length times width, right? Length times width to get your area. We deal with a square so much that the length and the width are identical, so it's L squared. But in this case, let's write down each cross section perpendicular to the x-axis is a rectangle whose height is 5 times the length of its base. Well, we know our length is always going to be this right here, right? This is our length. Let me do it in red. Our length is always going to be the length that we're given when we draw the top curve minus bottom curve. So we know our length is equal to top curve, which is the square root of x, minus e to the negative 3x. Okay, so let's read the question again. It's perpendicular to the x-axis is a rectangle whose height, so our height is 5 times, so 5 times the length. Well, we know the length is the square root of x minus e to the negative 3x. Bam. So what would be, find the volume of the solid? Well, it is a rectangle. We don't need to put the pi on the outside. No need for none of that nonsense. We're going to get the integral from the point of intersection, which is 0.23874. Sorry, I had to look over at my, 34. I had to look at my paper because I did write that down to 1. Well, it's length times width or height, right? I guess you can call this height if you want to. Length times height, and our length is always, you know, top curve minus bottom curve. So what is this? Well, it's going to be the length times width. So length is the square root of x minus e to the negative 3x, and the height is 5 square root of x minus e to the negative 3x. Boom, dx. Okay. Plug that into your calculator and you are in business. What I mean by that is you're ready to roll. Now, this looks a little weird, but the 5 is being these are all multiplying. We can move the 5 on the outside if we want to. So this could be 5 integral the point of intersection from 1, and we get the square root of x minus e to the negative 3x multiplied by the square root of x minus e to the negative 3x, which if you look, they're identical. So now we can write this as point of intersection 1, and believe it or not, we resemble, we get both of these, which is squared dx, right? Which is 5 times the length, really. So if you think about it, they're still going to multiply the 5 on the outside. We just pulled it out and then we got this expression, but we didn't have to do that. You could just plug this all into your calculator, boom boom, and you'll get 1.554, and you know you get your answer. And other than that, it should be pretty good. Hopefully that made sense. One thing I'd like to add to this video is if we were rotating this about a negative line, so let's say we were rotating this about a negative line, so we got something like this, right? Boom, we got this right here. And let's say we rotated it around the line -2. Just remember, the only difference is you're going to do big R minus little r. The only difference now is we're talking about radius, and so instead of being -2, it's 2 plus, because it's 2 right here, 2 plus our radius up above, which is the square root of x, and then little r is 2 plus than the bottom curve, which is e to the negative 3x, right? So just the only difference between rotating around a negative line and a positive line. But anyhow, take care, my friends.